Hello, my name is Alexa Udol, and today I'm going to present to you Lab 1 Charge Tapes from Physics 2212. The main purpose of the lab was to prepare pieces of charged tape, observe the interactions between a charged piece of tape and other objects, determine how much excess charge is on the pieces of tape, and compare the values with a computational model. The physics principles present in the lab experiment are the force of gravity near the surface of the Earth, the electric force or Coulomb's law, the electric field, Coulomb's constant, and Newton's second law. This is a preview of the results in which I found that the charge of the tape to be 1.4 e to the negative 8 coulombs, the number of excess electrons to be 8.75 e to the 10, and finally I found that the charged tapes had a positive charge. Here are the formulas that were used in this lab. As you can see here, all of the forces were calculated in the y-hat direction since we're only focusing on the forces in this direction. These are the formulas for the forces, the electric field, and Newton's second law is said to be F net equals 0, since later on it will be discovered that the electric and gravitational force cancel each other out when doing the second part of the experiment. This is the description of the experiment. Lab 1 had several different parts to its experiment. First, a piece of tape was placed flat on the surface, our base tape. Then the U-tape was made and placed on top of the base tape. U-tape had to be ripped off the base tape in order for it to be charged, and then placed on the edge of a surface to test it with different objects. When tested with the hand, the U-tape was attracted to it. When tested with a charged pen wrapped with my clothes, the U-tape was also attracted to it. However, when another charged tape was placed near it, the U-tape repelled it, hence confirming that the U-tape is positively charged. For the second part of the experiment, as you can see here, a charged tape was placed above another charged tape from a defined distance in order to calculate the amount of excess charge of the tape. In the part of the calculations, the initial conditions and calculations can be seen. A free body diagram for tape B of the second part of the experiment has been drawn, in which you can see that the force of gravity and electric force have the same magnitude and are in opposite directions, indicating that they will cancel out. This means that the force of gravity is equal to the electric force with an opposite sign, but in order to calculate the charge of the tape, the magnitudes of these forces were used. Isolating the charge of tape B gave the answer of 1.4 e to the negative 8 coulombs, which is the same answer that was obtained in my computational model. Furthermore, the area of the tape was calculated using its length and width. The number of atoms was calculated dividing the area of the tape by the approximate area of an atom, which equated to 4 to the e 17 atoms. For the last calculation, in order to find the ratio of the number of electrons, the charge of tape B had to be divided by the charge of a proton, which equated to 8.75 e to the 10 excess electrons. Here is a snippet of my code. As you can see here, I have all of the constant presents in order to determine the forces and all of the other calculations. Here I was able to create the tape A and tape B as objects. Here I calculated the forces acting on it, and I was able to calculate the R vector, R mag, R hat, and the charge on QB by manipulating the electric force formula. And finally, I was able to calculate the electric field on both of the point charges, as we're going to assume that they are. And finally, here we have the arrows which indicate the forces acting on tape B. These are the results obtained by the computational model. As you can see, tape B, modeled as a point charge, has both arrows indicating the forces acting on it. Also, here we can see the different results for the forces and charge of tape B. As previously seen, I got the same charge that I calculated using my initial conditions. However, there could be some sources of error present in my experiment regarding the correct distance between the tapes or how much the tape was handled with my hands. So for the what if in this part of the experiment, there would be no changes to the observations made, since the objects that attracted would still be attracted to one another, and the objects that repel each other would still repel each other, so that we would get the same results in this experiment. And finally, for the why part, is it important to handle the charged tape as little as possible? It is important to handle the charged tapes as little as possible. This is due to the fact that the charges on the tapes can be transferred to other objects, such as your hands. This could account for error and inaccurate results because the tapes would have had their charges altered.